The normal distributions. Let's say that in your college, the marks of the students, let's say that, let's talk about, not the GPA, let's talk about, okay, the marks out of 100 in statistics subject, okay? So the population here will be the students themselves who are taking statistics as a main subject, okay? And their marks will be the data. Okay?
Okay.
So if we said that the mean mark was, let's say the mean mark was 80 out of 100. This is the mean mark. And the rest of the marks will be normally distributed. What does it mean that the rest of the marks are normally distributed? That means that the mean will be located here in the middle, and the rest of the marks will be distributed like that. So the mean mark will have the most frequency. Okay, as you go up, the frequency increase. As you go down, the frequency decrease. Okay. So as you see, 80 divides this mountain into two halves. So the mean here will represent what? 0.5, okay, of the area. What do you mean there is 0.5 of the area? It means that the area before 80, which is the mean, represents a half of the area of this shape. Understood?
Yeah.
Perfect. And how about the rest of the marks? The rest of the marks will be distributed among something that we call standard deviation. Okay, let's assume that the standard deviation here will be, for example, 5. Okay, let's take it. Let's say it's 5. Okay, so 80 plus 5 will be here 85. 85 plus 5 will be 90. 90 plus 5 will be 95. And when you go down, 75, 70, 65. Okay, so as you see here, the number of students who have got 65 out of 100, they represent a very little number. Why? Because they represent a very little area out of the area of this shape, right or wrong?
Right.
Perfect. Okay. So the area of this shape, we call it the probability. Okay, perfect. So that means what? That means what is the probability of getting 80 as a mark? The probability will be what? Half. Why? Because 80 lies where?
Halfway.
Half the distance, right? Perfect.
Yeah.
Or half the area. Okay. So the
Right.
area in this shape represents what? The probability itself. Okay.
Okay.
Perfect. So this is the normal distribution. So when I say probability of X, what is X? X here will be our data, which will represent, let's say it will represent the marks, okay, X. So if I say probability of X less than 65, it means that the area before 65, which will be approximately 0.05, okay, or 5%, right or wrong?
Right.
Perfect.
Okay.
Okay, so here we will have something you must need to know first. Okay, what if I asked you about the probability of x less than 85, which means, I mean the probability, which means the area. Okay,
Mhm.
how can I get it? There are constant areas according to the standard deviations. Let's see. From 75, which is, how did we get 65? The mean minus the standard deviation that was 5. Okay, so we got 65. There's 75. Okay, 85, we've got it from the mean plus standard deviation. So the area between the mean minus standard deviation and the mean plus standard deviation, well, like in our example from 75 to 85, this area is, and it's constant, it is 60, from here to here, 34.1, and from here to here, 34.1. So yeah, it will be 68.2, and this is constant.
It's the
Okay.
standard deviation rule, right? Like there's like a 98% chance it's in the standard deviation if it's three deviations out and then like
Yes.
70 something
No,
percent.
no, no,
Okay.
no. The most is 3 standard deviation. This is the most.
Yeah.
3 from left, 3 from right, from the mean. Okay.
Right.
So this is how we got the areas or the probabilities. Okay, let's say, okay, and from 70 until, let's say from 70, which is mean minus 2 times standard deviation to mean minus standard deviation, from 70 to 75 will be 13.6. And so also here, 13.6. Okay.
Hmm.
And from 70 till 65 will be 2.1%. And from mean minus 3 standard deviation from 65 and going down, it will be 0.1%. And the same here, 2.1% and 0.1%. So if I asked you, what is the probability of x less than 85? So you will add these probabilities, right?
Okay.
Right or wrong, according to
Right. Yeah, yeah, yeah.
the normal distribution, right? Okay.
Okay.
If I asked you about the probability of x less than 90, so you will add 13.6 to 34.1, 34.1, 13.6, 2.1, 0.1, and so on. Okay. Okay.
Okay.
So, and the probability of less than 65, I'm sorry, it wasn't 0.05, so 0.1. Sorry, it was my mistake.
Okay.
0.
Yeah.
0. Yeah, 0.1%. Okay. So here, uh, what does that mean? What if I asked you the probability of x, let's say, less than 82? 82 is here, right?
Yeah.
But we don't know exactly the probability, right or wrong.
Yeah. Yeah, right.
Uh,
Yeah. I was gonna ask you
so
about that. I was gonna go like how.
Yes. So here we have advantages of constant standard deviations or constant numbers from standard deviations. We can get their areas, okay? And but what if we need numbers that are not mentioned here? How can we get their probabilities?
Yeah.
To get their probabilities, we will go to something that we call the Z score. What is that
Oh,
score?
yes.
I think
Yeah.
you have noticed this, right? The Z
Yeah.
score. How can I use that score to get probability of a number of x less than number in a data, which in which this data is normally distributed? Look, I need you to write this after me.
Okay. Sure.
Okay,
Uh, Z equals X minus M over. Okay.
perfect. Okay, we will get an example and we will see it live. First, before we go to the example, x is for the number like 85, like 82 that we were talking about. This is the population mean. This is the population standard deviation.
Okay.
Okay. Let's get an example, okay,
Yeah.
and see how can we get the probability of a number that wasn't mentioned in the standard deviations, okay, locations. Okay, let's read this example. A national study found the college students with jobs worked on average of 22 hours. Okay, so this is the population mean. Okay. This is the population mean, okay? The standard deviation is 9 hours. Okay, standard deviation is represented with this symbol, okay? Oh, we have here a
Yes.
college student with a job is selected at random. Find the probability that the student who works less than 4 hours per week. So here, X represents what? The number of hours, right? And we need to find the probability of X less than 4. Okay? So here, if we tried to use the normal distribution, so here is the mean is 22. 22 plus 9, it will be 31. 31 plus 9, 40. 40 plus 9, 49. 22 minus 9, 22 minus 9, 13. 13 minus 9 is 4.
Okay.
Okay. And then for we can't move
Oh,
because it will be negative. Okay. So
oh,
here 4 is located in this area, right? If we
ah.
found the probability, so we will find the area. This
And
is
it's
what is
two
probability
standard
of X.
deviations out, right?
We can use the standard deviations, okay?
Yeah.
But I don't
Okay.
want you to use the standard deviations because maybe you will find the number that is not in the same location of the standard deviations,
Oh, okay.
right?
Yeah, okay.
Okay, so let's consider 4 is not located. So we will
Sure.
use here the Z score. How can we do it? First, we have to find Z. And I will show you how can we use that Z here. The rule of Z is X minus U, population mean, over standard deviation. X here is 4. Okay, this is a question. 4 minus population mean, which is 22, over standard deviation, which is 9, right? Okay, do it
Mhm.
on your calculator, please, and tell me the exact answer. Hmm.
Calculator. Uh, -2.
-2. Okay, so Z is equal to -2. How can I use that Z? Look, probability of X less than 4 is the same in this question as probability of Z less than -2.
Mm.
Okay, great. So how can I get the probability of Z less than -2? So here we will use the Z table. Okay, let me show it to you. So as I said, because we moved the probability of X less than 4 to probability of Z less than -2, let's talk now about Z. What is Z? Z is numbers which are normally distributed. The mean is always 0. The most number is 3.4. The least number is -3.4. Okay.
Mm. Okay.
And when, let's say that I'm searching for -2. Where is -2? -2 is here, right?
Yeah.
Which represents what? Which represents a 4 in our in our original normal distribution for x, the number of hours, right?
Yeah,
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 so now we are comparing. Okay, so -2 is here. So if we can get the area here or the probability here, so the question now is done. So how can we do that? He said what? Said z less than -2. We will use this table to find the answer. This table is about what? Let's search for -2. We will search for what? -2.00. We have to use two decimals, okay? Look, where is -2.00?
yeah,
Here
right
it
there.
is. -2.00. So here it is. Its probability is what? 0.0228. So -2 here, its probability is 0.0228. And by the way, this table shows you probability of z less than a number, like here, like -2.
Yeah.
Okay. What if I asked you probability of z greater than -2? So we will do what?
It would be negative.
So we'll do 1 minus probability of z less than -2 because z greater than -2 we are searching here.
Oh, okay.
Okay. So this table will not help us to find the greater than -2, but it will help us to find less than -2. So we will do 1 minus the answer. Mm.
Okay, so
So
it's
0.0228 is what? It is probability of z less than -2. This
okay.
table shows you also always probability of z less than a certain number,
So
not
that's the
greater
answer?
than. Yes, so this is the answer. 0.0228 is the probability
Okay.
of x less than 4.
Okay. Mm. Okay, that makes sense. So you just put it into the formula, but why is it the point zero zero and not point zero one or point zero two? Like, why is it that one specifically?
What do you mean?
Like you said, you have to pick the first row of the point zero zero.
Yes,
Why is it?
because
What are all the other rows?
the z you have found already, wasn't it -2,
Yeah. Well,
which
it was
means
less than. So doesn't that mean it's
-2.00,
like,
right?
what isn't it less than? So doesn't that mean it's like negative 2.1?
No, it is -2.00. It was constant. It was a whole number, accurate number, -2. So I considered it -2.00,
Okay. Okay.
right? So I will search
Sure.
here for -2.00. How can I search it? This is -2, and I will go up and search for 0.00.
Oh,
So I will
okay.
match it here. So that's it.
That makes sense. Okay.
Okay. So 0.0228 is the probability, and if you want to convert it to percent, so it will be 2.28%, the same answer also.
Okay, that actually makes sense. Okay.
Perfect. Okay, let's
Yes.
answer another question. A survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes. So this is a population mean average. Okay, standard deviation 12.
Yeah.
Okay, normal distributed, blah, blah, blah. Okay, show methods. Okay. Find the probability that the shopper will be in the store for each interval of time listed below. Okay. When 200 shoppers enter the store, okay, how many shoppers would you expect to be in the store for each interval of time listed below? Okay, so how can we do that? First, we will find the probability first here in part A, and then we will talk about part B, which is the 200. Okay. First thing, we between 22 and 52 minutes, what is the probability that the shopper will be in this interval of time? Okay. So here we will have 2z. The first one is x, which is 22 minus 43, the mean, over the standard deviation, which is 12. Okay. And the second z will be 52x, which is x, minus 43, the mean, over 12. Okay, calculate these two numbers and tell me the two answers.
Um, there, 22, that's 43. Okay. Um, the 22 or Z1 is negative 1.75, and then Z2 is 0.75.
Perfect. So that means what? That means the probability of x between 52 to 22 is the same as what? Probability of z, okay, from 0.75 till negative 1.75, right or wrong? As I told
Right.
you, we always
Yeah.
match x to z, okay? Perfect.
Okay.
So okay, let's imagine the z normal distribution. We know that 0 is here as the normal mean, okay?
Yeah.
0.75 will be here. Negative 1.75 will be here. So we need to find this area, right? In the middle. So how can we get
Yeah.
this area? Okay, so think with me. How can we make it?
Um, well, um,
Hmm.
would you go to your chart, your Z chart?
Yeah, we will go already to the Z table. But before we go, that
Oh,
means if we know the probability of less than 0.75. So this is the whole probability of less than 0.75. And make it minus the probability of less than negative 1.75. So we will get this one, right?
right.
Perfect. So we need here to know the probability of Z less than 0.75 and make it minus probability of Z less than negative 1.75, right?
Yeah.
So we will search for in the table for 0.75 and search for negative 1.75. Let's go. 0.75. Zero. Okay, let's start by negative 1.75. Yeah, here it is. Look, here is negative 1.7, right? So I will
Yes.
search for what? Negative 1.75. This one,
Okay.
right? Right or wrong? Perfect. Okay,
Right. So it's 0.401.
perfect. This is the first. Now time for 0.75. 0.75, uh, yeah, here it is,
Yeah.
0.75, yeah. Okay, this is,
7734.
and now we make it minus, and you've got the answer.
Wait, was there a zero before the four? I thought it was 0.0401.
Okay,
I
say again?
thought. I thought it was 0.0401, but maybe I saw it incorrectly.
No, 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 in
Yeah, it is.
0.401, 401. Yeah,
But is that
zero, well, I'm sorry. Sorry, I didn't see the zero,
yeah,
sorry.
yeah, yeah.
Okay, that's it. Mm,
Then I subtract it?
yeah, and this is your
Okay.
answer now.
Uh 0.77. So 0.7333.
Keep it because we will use it now again. Why?
Okay.
Now we have solved the first A. Now we will solve B. He is asking about what? So the probability of, say, the number 0.7, right? 3.
7333.
So if we have 200 shoppers enter the store, how many shoppers would you expect it to be in this interval? Okay, so we found the probability is 0.733. So we'll make it times 200 to find exactly how many shoppers will be in this interval of time, right or wrong?
Okay. Right. Okay, so that because that's the probability. So you're just saying it's
Yeah.
73% chance of these 200 shoppers.
Yes.
So 146.6.
Yeah. Yeah, so it will be 147 shoppers. So
Okay.
you have to, yeah, you have to make it whole number. Okay, the
Okay, yeah,
meeting will
round up.
end. I will send you another link. Okay.